Welcome back. Now, we are going to go over Chapter 10. If you don't have Chapter 10 downloaded, if you click on the notes page, the top the purple thing that says Chapter 10, you can download a PDF and print it out yourself. Or if you don't have a printer, just copy the stuff in a notebook and follow along with this. All right? And follow on the computer as well. Here we go. Chapter 10, circles. What we're going to be covering first is we're going to take out areas and sectors, finding arc measurements, finding lengths and circles, areas, sectors, and circles, and review. Give you guys a little test on that. And then we're going to do the rest of Chapter 10, including a little bit of 9.3, which is writing and graphing equations of circles. All right, so this is pretty much broken into two parts, 10.1 and then 10.2 and the rest. All right, so we're going to start today with finding arc measures. Now, if you're having a problem using the calculator on the NJSLA site, you can always use the one on Desmos. That's pretty easy. You can use the calculator on your phone or any other place you want, because now we don't have to use the trig function, so it's a little easier. All right, today we're going over arcs and sectors. All right, so we're going to find arc measurements. The way we're going to do that is we're going to find the measurements of what a major and minor arc is. We're going to use the central angle measurements of a circle to find the actual arc measurements. And you're going to know what all that stuff means. Find the measures of a major and minor arcs and use the arc postulate to determine a larger or smaller arc size. And I hope you like my new tiger. He's underwater, in case you didn't notice. All right, so normally in class what we would do is we'd go over this stuff, you'd help. So now what you could do is you could just shout it at home and maybe get the same answer. So what do you think a central angle is? You're supposed to yell it out. I can't hear you, but it'll be okay. So what it is actually an angle whose vertex is in the center of a circle. All right, so this is your circle. Your central angle would be the angle of the inside. So that would be your center of your circle. And whatever the two radii touch the center of the circle, whatever angle they meet, that is your central angle. Now, we're going to use that central angle to create a minor arc. What's a minor arc? Yell it out. When I point to yell it out. All right, it should be a part of a circle. Now, what part of a circle do you think it is? It's the one that's the smaller part, the one that's under 180 degrees. 180 is half a circle, so if the angle is less than 180, it's a minor arc, okay? Right here, your minor arc would be AB, right? Now, major arc is also a part of a circle, but it's not the measure that's less than 180, it's greater than 180. Okay, so it wouldn't be AB, it'd be ADB or BDA, okay? The key is you say the middle letter between the two endpoints has to be in the middle, right? So that's your major arc, major and a minor, right? Semicircle, what do you think a semicircle is? All right, you should have got half a circle, and that's how many degrees? 180 degrees, all right? So the endpoints are actually the diameter. So right here you have a diameter. What happens is both endpoints of the diameter create two semicircles. They're both the same and they both have 180 degrees because a straight line is 180 degrees. Measure of a minor arc. Now, minor arc we know is less than 180. So to find the measure, you have to find the measure of its central angle. So in this case right here, it's 55 degrees. So since the central angle is 55, the actual arc is 55. The angle is the same as the arc. They both share the same measurement. So how do you think you find the measure of this major arc? Using the minor one. So how many degrees is a circle? Yep, it's 360. So you're going to take the measure of the central angle right here, and you're going to do what with it? ADB. So it's not 55, it's going to be 360 minus 55, which is 305. So if this is 55, this right here is 305. Right? Congruent circles. You remember what the word congruent means? Congruent means the same. So congruent circles would be the same size circles. Whoop, right here, look at A and B. Now to be the same size, you need two things. You need either the same radius or the same diameter. That's it. Congruent arcs. How do you think something's congruent arcs? Doesn't necessarily have to be in the same circle, but if it is, it's easiest. Oh, the same radius. Sorry. So right here, radius is the same, therefore the circles are the same. Also diameter, like I said before. So congruent arcs have congruent measurements, meaning the central angles are the same. they also have to have a circle with the same radius, okay? So this is the same circle, so the radius is obviously the same. But if you had these two circles, you can also have congruent arcs there because they have the same radius. But then you would just need the same central angle. So in this case, both these angles are 45. That's one check, same measurements. Congruent circle because it's the same circle, so that means that this arc right here is congruent to that arc right there. And how do we show arcs are congruent? We should draw the line. The same congruent line we used for side lengths, we use for arcs. All right? So that's all the words you're going to need to know. I know it's a lot of words, but hopefully you're good. So let's go over how to actually measure an arc. The measure of a minor arc is the measure of its central angle. The expression of measure, the M stands for measure of AB, is read up as the measure of arc AB. The little M in front means you're actually finding the angle measurement, so it's going to be in degrees. Since the measure of the circle is, how many degrees is a circle? Yep, 360. The measures of the major arc is the difference between blank and the measure of the minor arc. Yep, 360. And the measure of any semicircles, we said before, is 180. Very good. See, you guys got this. Now, let's look at two examples right here. What is the measure of AB? Now, AB is this arc right here. If you said 50, you were correct because it's the measure of the central angle. Now, how do we find the measure of ADB? Well, you go look at A to D to B is that blue arc right there. So to find the measurement, since these both add up to the whole circle, we said a circle before is 360. So you take 360 and you subtract 50. When you do that, you get exactly 310 degrees. Easy as pie. Why don't you guys attempt number 2? All right, let's look. Measure of AB. Now we know ADB, this angle right here is 305. So this angle would be just the opposite of this. You take 360 once again and subtract 305. And as an answer, you should get 55 degrees. And that's how you find measuring arcs. Very simple lesson. You guys all got this. Now we're going to attempt problem number 3. Find the measure of each arc where DF is the diameter. So try this on your own, then we will go over it. So first off, DE right here, 117 degrees. What type of arc is it? It is indeed a minor arc because it's under 180 degrees. Can we find the actual angle? It's the same as the central angle. So it's the angle DCE, which is 117 degrees. Good. Next, what is DFE? So nope, you have to go this way. DFE is indeed exactly a major arc because it's greater than 180. What is the measurement here? Well, since this is 117, a whole circle is 360. 360 minus 117 equals indeed 243 degrees. DF is a diameter, all right? So that means that DEF, what do we got here? DEF, this whole arc right here, is a semicircle. Semicircles equal how many degrees? 180 degrees. Excellent. Let's try some more examples. Problem number 4, what I want you guys here to do is find the measure of RTS. Good. So way to find the measure of RTS, R to T to S is right around here. It's not 45. 45 is the minor arc. This is the major arc. So you're going to do 360 minus 45, the measure of arc RS, and you get 315. Why don't you guys attempt problem number 5? Good. RS. RS is the same as the angle, the central angle. That's 10 degrees. RS is also 110. RTS, from R to T to S, is the major arc right there. So once again, circles are 360. 360 minus 110 equals 250. Awesome. RST uses RT, which is my diameter. Semicircles, so it's 180 degrees, once again, because it is a semicircle. All right. Any questions with question number 4 or 5, please email me. All right. We're going to throw a little wrinkle in here. This isn't very difficult, but it's pretty simple. We have the addition postulate, all right? The measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. Very similar to the way I would say the segment addition postulate worked, or the angle addition postulate worked, just with arcs. So remember the segment, say I had one line segment that was 5, the other one that was 4. If I combined them together, 5 plus 4 was 9, right? Remember the angle addition postulate? If I had one angle right here that was, say, 30 degrees, one right here that was like 60 degrees, you add the two angles together, you get 90. You're doing the same thing with the measurements of the arc right here. So the measure of RST, this entire angle, is the measures of what two arc angles? Which two? It should be RS and the measure of ST. Now remember, when you say measure, that's actually giving an actual number value. That's why we use an equal sign as opposed to a congruent sign. So what I want you guys to do is try problems 6 through 11. Awesome. So TQ, right there, central equals 120. TQ is also 120. QS. Now we can either do this way or this way. There's two ways to go because they only give us two letters. Now, since it's only two letters, it has to be a minor arc, meaning it has to be under 180. Way to do this is draw like a straight line. Well, this one's more than 180 if we go this way, so we have to go the other way. Oh, wait, we're doing QRT. Oh, right up. Save that information for later. QRT, in that order, 60 plus 80 plus whatever that is, or 360 minus 120. 360 minus 120 is indeed 240. TQR, add these two, 120 and 60, gives you a semicircle, which is 180. Now we're back to QS. Okay, so now we're QS, we know it's the minor. We need to know what this angle is. So, we know that these three angles, plus whatever that fourth angle is, add up to 360. So what we're going to have to do is we're going to have to figure out this angle first. 360 equals 80, 120, 60 plus whatever that is, I'll just call it X. 200 plus 60 is 260. Subtract 260 from both sides, and you get X equals 100 degrees. All right? So this is 100, but that's not our answer. We want Q to S. So it includes both of those. 60 plus 100 is indeed 160 degrees. All right? Awesome. TS. 80 degrees. That was an easy one. RST. RST. Also easy. You're just adding two things together. Another semicircle. 80 plus 100 is 180. Got it? See, told you. Simple lesson. Now what we're going to do is we're going to add in something. We're going to add in a real life situation here. So this stuff, you really just don't go around, running around town going, oh, look, there's a circle. Let me find out the angle measurements of that. But in real businesses like banking, like economics, even business, like regular, like a small business owner, would use circle graphs to distinguish what they have with things, especially like money-wise. And then they take those numbers, these angles eventually, and convert it into money, stuff like that. But you always start somewhere. So you start here. So they have their stuff right here. You join a new, here you go, bank. And divide your money several ways. All right. This is the circle graph telling you the angles of each thing. So you want to know some interesting information. So what's the measure of BD? So we can either go long or short. BD, once again, is a minor arc we need. So we're going to add BA plus AD, the checking and the savings. When you add them together, you guys should add 55 plus 105 and get 160. Good. So find BCD. Go. Excellent. So an easy way to do this is 360 minus the answer we just found, because the major arc, which is 200. You could also go 140 plus 60 and get 200 as well. Now do 14 and 15. Awesome. So 14, BCA, B, C, A. So pretty much it's everything but the 55. So you just do 360 minus 55 and get 305. Or 140 plus 60 plus 105 gives you 305 as well. Some people only like to add 100% okay. All right? Doesn't matter. ABC. A, B, C. 55 plus 40. 140 equals 195. Got it? Hopefully you have no questions yet. Let's move on. This was the thing you do now, but we'll do it right now. So why don't you guys try it and go. All right, hopefully you're done. Now, really quick, I want you guys to say out loud, who would you be? 1, 2, 3, inventor. I'd rather meet an inventor. I guess that's because I'm not a teenager anymore. They asked teenagers would they rather meet a famous musician, actor, inventor, or other person as shown in the circle graph. So, measure of AC. A. C. Nope. Got to go minor arc. That's the inventor and the musician you're adding together. And you should have gotten 137. ACD. A, C, nope. These have to be the endpoints, and the C has to be between the A and the D. So you're going A to C to D. That's an inventor, a musician, and an athlete. You feel like you're in 2nd grade again. 220 degrees. Got it? ADC. ADC. 79, 61, and 83. You're adding them all together. And as an answer, you should get 223 degrees. EBD. EBD says everything but 61. So I just subtract 61 and get 299. This, and this, all added together also gives you 299. Got it? Hopefully you did well. Now what we're going to do is we're going to deal with congruent arcs. Now congruent arcs are fairly simple. So what you do is, remember, to be a congruent arc, you need 2 things the same. You need to have the same congruent circle, and you need to have the same angle measurement. So R, BC, and DE congruent. Yes, they are congruent because they're in the same circle, and the 2 angles are both 75, so they are equal. Remember, angle measurements are equal, actual arcs are congruent. So why don't you guys try B and C? All right, B, A, B, and C, D have the same, what do they have? A, B, C, D have the same angle measurement, so that's one thing. Are they in the same circle, or do they have congruent circles? No, they are not congruent because the arcs in the circles that are not congruent. So the circles here are different sizes, therefore they are not congruent. So C, FG, and HJ. What do you think? Yes, they are congruent. FG, HJ are congruent because they are in congruent circles. How do we know the circles are congruent? Because see these little green lines right here? Those are congruent radiuses. We have congruent radiuses, the circles are congruent. Now, are the angles congruent? Yes, they are both. How many degrees? Same radii. They are equal because they are both 90 degrees. All right? Now you're going to try some examples on your own. I want you guys to try 17 through 21. Go. All right, time to go over them. Now, answer you should have got was, yell it out. Congruent. Let's see why. Because angle measurements are the same and they're in the same circle. 18, you should have got not congruent. Oh. Angle measurements is both 90, but however, the circles are different sizes. The red circle's a little bit smaller. 19, you should have got congruent. Same radius means the circles are congruent. Same angle measurement means the answer is congruent. Ready? For number 20, A, B, and C, D, you should get congruent again. The radius are the same, therefore the circles are the same. Measurements are the same, therefore they're good. All right, this one right here. Oh, you should get not congruent. Ooh, 120, 120, they're the same. But however, radiuses are different sizes. Even though they're just slightly different sizes, it's still not congruent. Got it? All right, circles are different sizes. So let's go over the last thing. This would have been your homework, but since we do not have any, we'll just do it right now. Ready? Everyone try it? Go. And now it's time to go over. Now, what I would do here first, I'll give you a hint if you haven't started yet, is fill in each one of these angles. So find each one of those based on what you're given. Now remember, EB and AC are straight lines, so they are semicircles, meaning they total up to 180. Ready? So if you need more time, pause it, go again. Here we go. I'm going to find AB first. 180 minus 70 gives me 110. Now, since this is 70, these are both straight lines. This is 70. That's 70 because they are vertical angles. Last I'm going to find, these 3 angles add up to 180. 45, 70 plus DC is 180. So 180 minus 115 gives me 65. All right? Use this information to solve. So BC. Now watch how easy this is right now. BC is 70. So that angle is 70. Number 2, DC. DC is 65 right here. That's 65. DB. Nope, I have to go the short way. Add the 2 angles together because we found it before. 65 plus 70 is indeed 135 degrees. AE. Central angle is 70. Measurement of the arc is also 70. AD. Nope, this one. Add these 2. 70 and 45 is indeed 115. A, B, C. A, B, C. Semicircle. A, C, D. A, C, D. So it includes the 180 and a 65. 110, 70, 65. And that should give you 245. And last one, EAC. E to A to C. So you got 70, 110, 70, which gives you 250. So hopefully you got all the arc measurements correct. So last one, tell if the arcs are congruent and why or why not. 180. Is it congruent? Well, we don't need that 180. Since this is 70, we have to find this angle right here before we even do anything. So these, all three of those add up to 180, right? So 180 minus 70 and 140. 70 and 40 is 180 minus 110. Gives you 70. Arc AB and DC. So now, once again, are they congruent? Same circle, same measurement. They are indeed congruent. All right. How you feeling? Good? LP and MN. Same measurement, but different circles, so they are not congruent. And the last one. VW and that one. They're actually congruent. So that might have tricked some people. 8 right here is the radius. 16 right here is the diameter. So half of 16 is 8. So they have the same radiuses. Therefore, the circles are the same. So hopefully you did well in this lesson, and hopefully you're doing well in general. I'll see you next time.